Amazon EC2 to launch your own mini-scalable cluster. Meaning you can scale it as large as you want, theoretically. And I'm going to focus on how you can parallelize Python code using some MPI libraries. I do a lot of work with like MPI and SciPy, and I just found that to be a quick and easy way to get it done in this routine. So here's kind of an overview. The one thing I'd like you to take away when you come out of here is, to be able to just, sign up for Amazon, launch your own cluster, and play around with doing some parallel programming if you're not familiar with it. I'm not going to go too into detail into any one of the subjects. There's a lot of depth you can go into EC2, MPI. We're just going to kind of breeze through some things and show some demos. So, motivation for this, I'm pretty interested in machine learning and data mining. That's the kind of thing I do. And when the Netflix prize was announced last year, I thought that was a really great idea, and I wanted to start digging into data. I like large data sets and playing around with them. And the basic idea, if you haven't heard of it, is that Netflix has a contest where you win $1 million if you improve the accuracy of their movie recommendations by 10%. And they give you a big data dump, and you go to work on it, and you submit your guesses for a holdout set. Now, when it was first launched, everyone said, "Wow, this is a huge data set." It's not really that big, compared to like search data, something like that. But for collaborative filtering, it's pretty sizable in terms of publicly available data. And what ended up happening is this community just kind of developed, and people just started posting library and started playing with it. There weren't a lot of algorithms on your laptop. You need a cluster to do some basic stuff. You can get up to like 4 or 5% improvement with some easy algorithms. But then score so far, 50 grand. And it was a team from Bell Labs, and they merged the results from over 107 different, slate algorithm runs. Not really that many algorithms, but variants on things. But the upshot is that you're doing okay for a while, but if you really want to do some serious crunching, you need to do a lot of different runs, and you need more horsepower. But that's a problem if you're, working at home and you don't really have the resources. And so you ask yourself, okay, if I have very limited resources, how can I, get myself a cluster? And again, some people might not be familiar with like Beowulf clusters. Generally, the idea is, that okay, let's use commodity hardware and network them together, a bunch of identical machines, and use message passing, some kind of paradigm, parallel programming paradigm to spawn out your work. Now, enter Amazon EC2, right? So I don't have the resources to buy a whole server farm, and there's the overhead and management, heating, cooling, all that kind of stuff. Amazon is great to take care of that for you, right? So Amazon EC2, the idea is that they have all these spare cycles. They built up all this infrastructure to handle the peaks on holidays, for their websites, and they wanted to rent it out, and it's just really, obviously, it's taken off. Everybody's into it, and it makes it really easy. You can just access a web API and dynamically do stuff, launch instances, cluster them together. And here's just some details. The upshot is it's 10 cents per wall hour per core. And they have these extra large images where you basically get a whole box, and you get a gigabit bandwidth, gigabit Ethernet bandwidth, effectively. Now, I'm not going to go into too much detail into how to actually talk to Amazon. There's another talk later today that actually goes into that in more detail, I think, so you should check that out. These are the basics, right? References. I'm gonna for our purposes, it's just magic, right? You can check out the code later on in Google Code. It's pretty basic. REST SOAP API. Similarly for parallel programming, I'm not going to cover everything under the sun, right? There's huge battles about okay, what's fast, and there's all kinds of different ways to do it. For me, a lot of my prototyping is done in MPI and SciPy. What I want is something to easily parallelize that. And there's a great project that's coming up now. It's IPython 1. It's really starting to get some traction. And it can sit on top of MPI, and you can drive all these massively parallel applications with it. It's really cool. And I'll try to demo that a little bit at the end. So that's built into this elastic wolf cluster, which you run on the images and scripts. So you can get yourself up and running. You don't have to worry about figuring it all and installing it exactly from the game sometimes. But what I'm going to be focusing on in the code examples is PyMPI, which is pretty simple to use to give you the basic principles, so you can start playing around yourself. All right, so Elastic Wolf. Now, like I said, Amazon lets you launch these instances. What does that mean? So basically, they have a Zen farm out there, and you programmatically they store these images, machine images, on S3, and when you programmatically launch it, it provisions the machines, and they boot up, and it takes a couple minutes. You're ready to go. So the images that I put together have all kinds of good stuff for you, just your basic, how to build the Babel beginner kind of thing. It's got NFS, Ganglia, X windows, stuff you might find useful even if you're not using a cluster, I guess. And all the numericals, Python kind of stuff. So once we fire that up, you want to actually start playing around with some parallel programming, and it's good to know something about MPI, so you can start parallelizing your code. And we'll just cover a little bit of the basics here. It's a message passing interface specification. So it's pretty powerful. You can make any node talk to any other node, do all kinds of operations. It's pretty complex too, and it can be hard to debug. That's why I think IPython 1 for people starting out might be a better way to go, especially if you have just some embarrassingly parallel stuff and you just want to get it really quick. You want to check that out. But if you have existing code, I mean, there's just a huge code base of things. Mike Carrioso is here. He has a project called RunBlast, which is doing basically the same thing, but focused on bioinformatics. It has a Python GUI, so you can go run stuff on the genome. So that's pretty cool. Now, I'm going to kind of skip through this. So basically, there's a bunch of primitive operations for nodes to talk to each other. And it might help to look at some code. So we're going to again, look at PyMPI. The syntax is fairly similar to MPI for Py. Look back here. So there are a couple key things to know. So there's a size attribute and a rank attribute that are associated with each process. Corresponds to a core or a CPU. And the size is the total number of processes. So when you boot these MPI units, then the total number of them is the size, and the rank is unique identifier from 0 to n-1. So some basic operations. If you're using something like NumPy, a typical use case might be I have a bunch of data and I want to broadcast it out to all the nodes. So that's where MPI broadcast comes in, right? And it does just what it sounds. It sends a copy of the entire array, right? MPI scatter analogously breaks it up into chunks and scatters it evenly across the nodes. And what you're seeing here with this, if rank equals 0, that's the same program is running on all the nodes. So say you have an NFS mounted or PBFS mounted home directory, then this Python file will be sitting on all the nodes, and it's executing on all the nodes, and they know what rank they are, and that's how you control the flow of the program. Once you've sent the stuff out, you've done some computations, you want to pull it all back in. Again, this is just one paradigm in MPI. There's a lot of different things you can do. This is the kind of master worker, send stuff out, bring it back in. So gather does just what it sounds like. You're bringing it back in. So I sent my array out, did some calculations on it, and I gather it back, the entire thing. And MPI reduce, there's a lot of buzz about MapReduce, Hadoop, Google, MapReduce, and again, I think that's some great stuff. I use nudging to do crawls. I think it's a lot of fun. But this is kind of analogous, right? So you're reducing something, you're doing an operation on it, bringing it back in. Now, quick example, it's Pi Day, and it's appropriate, I guess. Calculating pi, a Monte Carlo example. The kind of basic programming thing, using areas to estimate pi. You do a whole bunch of random runs, throwing darts or picking points, and the ratio of the area of the box to the quarter circle gives you an estimate of pi. So if you're going to do that in serial code, it might look something like this, and you're running some n number of samples. If you're doing it in parallel, you are effectively, this is an embarrassingly parallel problem, right? So you can do the same amount of work on all the nodes. And if you're going to parallelize, it, it's pretty simple to do, right? So you get the MPI rank, MPI size, and the same code is running on all the machines, and then you're just pulling the results back and summing them up. Because all you care about is the count of the points that were inside the semicircle versus outside. All right, so that's just to give you a flavor of what you can do and how you can scale your work. So that would scale roughly with the number of nodes that you have. So how do you actually get going? Again, it'll be on Google Code. I'm going to show some screenshots. I wasn't sure if the network would be working. Maybe we'll have a little time. Actually, we should probably get going here. So let's still show some screenshots. You just actually, once you get the scripts, you can start it up, and it'll tell you, these nodes are running. You can check, make sure they're running. Once everything's been started, it might take a couple minutes. You run this config script, which passes keys around, so make sure they can all talk to each other over SSH, and configures the NFS, and stuff like that. Starts with Ganglia. And then you can just log in, LAM user, non-root user, and you can boot the MPI daemon processes. And it comes, again, with a whole bunch of stuff all built in, so pretty much any tutorial you find, you can just pick up and run. The libraries are all installed. And here's some MPI for PyCode, I mentioned that. We're running short on time, so I'll just kind of flip through these quick, and we can get to stuff with questions, hopefully. It comes with Ganglia interface, you can monitor. There's all kinds of things that will happen in EC2, it's still beta. You might want to see what's running, how it's doing, or something wrong with the machine. And here is just a quick look at the IPython 1 controller. So again, there's a master worker paradigm there. So IPython 1, you start a controller process, and then you start up these engines, and you use you can use MPI run to boot them all on all the machines using MPI. And then once it's there, you can log in, and X Windows, you can log in, you can do interactive parallel stuff and plot your big data set in PyLab, Matplotlib. And I don't know we'll have a huge amount of time to talk about this, but definitely check out the tutorials on Python 1 if you're interested in this. And it's a lot simpler than doing raw MPI stuff. And And getting back to the whole point of this, so why was I doing all this, right? So there are a lot of algorithms, for cloud rate filtering and things like that scale really well. Even with, I should mention, so the latency, if you're used to really high performance computing, this is just gigabit commodity clusters on Amazon. And there's a bunch of network hops it has to do sometimes for them to talk to each other. They could start up in different buildings, even in their data center. So I wouldn't count on super high. You don't want something that's very finely grained parallel running on here. But for most of the bulkier work, you can probably get away with it. And here's an example for K-nearest neighbors algorithm. Find the closest movie. That's something that scales very well in this kind of programming paradigm. And yeah, so I think we're about done. I can mention some of these things when we get to questions. And oh, I have 10 minutes? Oh, okay, I'm sorry. So I was kind of breezing through, I guess. Well, this is good, so we have some time to actually start something up. So we'll get back to the EC2 gotchas, I guess, later. I'll just mention briefly that it's in beta. There are also little quirky things to watch out for, and you can check out my delicious links, and I'll keep track of what's things to watch out for. When you're bundling these images, there's two ways to do it, right? So you can launch an instance out there, SSH in, start adding libraries, then rebundle it and store it on S3, or you can chroot on your Ubuntu machine or whatever, and then create your image there, and then shuffle it up to S3. When you use their bundle tools, they do certain things to the default configurations that you can override. So you want to look into that. It does some magic that you might not be aware of. Also, the subnets are dynamic. There's no multicast. Things like that you have to watch out for. Your app might not run exactly. So now I think I'm going to maybe we'll switch. Let's just log in. I booted up. I wasn't sure with all the network stuff going on if we were going to be okay, but I think it's working. So 5 minutes. Yeah, why don't I take some questions? We'll boot it up and show some commands and stuff.
I'll run around as best I can, but if people could start lining up out over here or in the middle.
Sure.
Questions? This will be the last time I run. So start coming down the center aisle if you want to ask a question.
How do you handle oversubscription on devices?
What do you mean by
like multiple people trying to run the same hardware?
So yeah, okay. So there's two things there. So this is a private. There's security groups, so it's a private network. So this is really a personal Beowulf. I didn't even bother putting in user management and all that kind of stuff. And in terms of subscribing the same physical box, right? It's not like your typical shared hosting where they pile on 200 people or something. It's more equivalent to a dedicated server. For the small instances, you're sharing bandwidth, and that's going to suck. But if you're on the extra large, you're effectively getting the whole box yourself.
So what you were talking about is that you have instances of the same program running on different nodes. A different concept is that you have the interpreter itself distributed. What is the state of development with respect to that?
I don't know too much detail about that. I think the references, if you check out those references on the slide, talk to people like Brian Granger, PyCon guys. I think they'd be able to help you out.
With respect to your Netflix competition, I was wondering if you tried storing data that you get from it or the data you need for it in
Yes.
simple DB.
No, so that's a good point. So another gotcha to point out is that S3 EC2 communication works really well if things are, if you have them chunked, right? So you can take full advantage of the communication, TCP optimization, stuff like that. And I haven't played around with SimpleDB. I signed up, haven't gotten around to it yet. But that's another great example. Also having Nuke on there, you have a distributed file system. You access things pretty quickly that way. So, oh yeah, I can show really quickly. SSH in here. So here we are. We're in Amazon. So we have to. You have to boot up. You saw in the screenshots before what we're going to do. All right. So you've got some. You've got all the libraries in there. You can boot them up, play around. There's code examples. Let's see. Let's exit out of here. So you can see here we're running 5 instances. So this is equivalent to 32 cores. And I think I have. All right, so you can see you got some stuff in here. I just recently got the IPython 1 stuff working, so I'd recommend playing around with that. I've got PyFlix in there, if you want to start, crunching Netflix data, and you'll have to put it up on S3 and then blast it out to the nodes. That's the way to go, or something. Any other questions? Oh. Oh, okay, great. All right, well, let's just look around here. So, all right, there's Ganglia. Let me slow down a little bit. Okay, so we've got next window started. We're in here. Let's see if I have to. Alright, so now I just started the MPI daemons, and you can see that we've got the 4 nodes, and each of those has 8 cores. We can do start up IPython. I don't know if this is the best, best use of my time. Actually, why don't I ask you guys, what would you like to see? Anything in particular? Win the Netflix prize. Okay. Okay. Oh. Yeah, all right, so you got your basic stuff here. That's not super interesting. So what is probably interesting is starting up on Python. Okay, there we go. Okay, so once the master started, what we want to do is start up the worker units. Yeah, you want to. Right. So what's happening here is we're start up the controller, and we have all these we have these engines that we want to start up, and we're going to use MPI run do that. Oh, bad enough manage. There we go. So we're going to do 32 engines. All right, so that's running. Amazon likes one URL, so.
I'll throw one question out, real quick question.
Yeah.
as you're doing that. You say that Amazon freezes or you lose nodes. When something like that happens, how recoverable is this environment? If the folder goes down, does the whole thing just kind of blow up, you have to restart it, or
Yeah.
what do you do when you run into
Okay,
this?
so especially, yeah, when you're running MPI, that's a good point. So there were a bunch of times where they had a failure, and it could be something like ENS or something like that. And in that case, your MPI job is basically hosed, right? So MPI, you want to be checkpointing it and stuff like that. You can totally lose your state if you lose a few nodes. So another thing you want to watch out for. Yeah, sometimes you can't SSH in. You just go through the forums and you'll see all these little bugs. But I'd say like 95% of the time it's perfectly fine, or probably more 99% of the time. But there have been about 3 or 4 instances where I just lost the cluster. So you want to watch out for that. All right, I'm going to skip the demo, the rest of the demo. Yeah, maybe I'll go back to this slides here.
Oh, okay, I'm sorry.
Oh, yeah, go.
Already.